Okay, now we need to know how to test for an aldehyde. Right, just to recap, so an aldehyde is a fairly new functional group we've come across, and it contains the carbonyl group, which is that a carbon-oxygen double bond. Okay. Now we have an aldehyde where that carbonyl group is on the end of the carbon chain, so that means that's just a hydrogen there. That's an aldehyde. And we have a ketone where the carbonyl group is not on the end of the chain. It's, you know, two other carbons attached. So let's say that's like that. We do more about these in a later topic, but this is a ketone. That's the smallest ketone you can have, and you can't have them 2 carbons long. This one would be called ethanol, and this one is called propanone. Ketones end in -one. Now, if you remember, the if you get a primary alcohol, you can oxidize it first of all to an aldehyde, and you can oxidize it even more to a carboxylic acid. Whereas a secondary alcohol doesn't give you the aldehyde, that gives you a ketone. And you can't oxidize a ketone anymore. That's the end of it. And just for the sake of completion, a tertiary alcohol, well, you can't oxidize that at all with weak oxidizing agents, with oxidizing agents. Okay, so the way we distinguish between an aldehyde and a ketone is because, well, we can see that aldehydes, they can be oxidized. Now, if something can be oxidized, it means, i.e., it is a reducing agent. Whereas ketones, these are not a reducing agent. So the way we test for an aldehyde, we can see can it reduce something. So we get a reagent and see if it can reduce it. Now there are two tests. Okay, I'll do the first one, but they both work the same fact that aldehydes are reducing agents. The first one is called Fehling's test. Okay, so it's named after a man. Fehling's test. Okay, now what you do is you basically you get your test tube, and this is going to be your Fehling's reagent in here. Okay, and we'll tell you what that is in a minute. And it contains copper 2+ ions. Okay, and it's a blue color. Right, then you're going to put in a few drops of aldehyde, or what you think might be an aldehyde. You warm it up, and if you do have an aldehyde in there, what happens is it goes a bit cloudy, and you get a brick red. It's usually described as a brick red precipitate forms. Okay, now if you try this with a ketone, nothing happens at all. The Fehling's reagent stays the blue color. You don't get the brick red precipitate. So let's just look at the chemistry of it. Well, what you've got there is you've got copper 2+ ions in aqueous solution, and they become reduced to by the aldehyde to copper 1 oxide, Cu2O, which is a brick red precipitate. That's what's happening there. You see the oxidation number of the copper here is obviously +2. The oxidation number of the copper here is only +1. Copper's a transition metal. Quite often they have multiple oxidation states. Okay, so that's Fehling's test. Using Fehling's reagent. What happens in the process there is, well, the aldehyde gets oxidized by the Fehlings, what's it going to get oxidized to? If you oxidize an aldehyde, what do you get? You get a carboxylic acid. Okay, and this test is a specific for aldehydes. It won't work with anything else. It's very similar to Benedict's test, which are used in biology. And Benedict's test is called, maybe remember, you say it's testing for a reducing sugar. Well, why is it reducing? Because it's got an aldehyde group in it, and you can oxidize an aldehyde. Okay. Whereas you might think non-reducing sugar like fructose, that isn't an aldehyde, that's got a carbonyl in it, but that's a ketone. You can't oxidize it. So Fehling's test and Benedict's test are both use copper 2+ ions. It's essentially the same thing. Right, now there is another test as well, and you should know about both, and this does the same thing. It tests for aldehydes. It's called Tollen's test, okay? Sometimes called the silver mirror test. Okay, so what you do with Tollen's test is you get you get your Tollen's reagent in your test tube. And what Tollen's reagent is, it's Ag+ ions in ammonia solution. And you heat that up. Right, you've had a bit of aldehyde, yeah. That's going to be, so this is clear and colorless. You add a bit of your suspected aldehyde, and you warm it. And if you do have an aldehyde present, what happens is the silver gets reduced to Ag metal. Okay. So that means you end up with, and let's see if we've got a nice silver color here. Yeah, maybe that. Okay. No, that's not silver, is it? Nice silver color, yeah. So a silver mirror forms on the inside of the test tube. Right, that test is specific for aldehydes. It will only pick up an aldehyde. Well, while we're here, let's just talk a little bit about potassium dichromate, acidified potassium dichromate, so K2Cr2O7, and sulfuric acid. It's acidified, yeah. All right, that's orange, and when it gets reduced, it will go to green Cr3+. Now, so potassium dichromate is the oxidizing agent. So what reducing agents can react with that? Well, we've seen a primary alcohol can't it? Because the reducing agent gets oxidized, yeah? A secondary alcohol. And we can see here also an aldehyde, yeah? Because an aldehyde, you can oxidize it to a carboxylic acid, can't you? So all three of those, they will all give you this orange to green color change, but it won't tell you which one you've got. You won't know if you've got a primary, secondary alcohol or an aldehyde. The only thing you know you haven't got is a tertiary alcohol. Whereas with Fehling's and Tollen's, these are just for aldehydes only. They won't react with primary or secondary alcohols. So they are specific tests for aldehydes. Okay, I think we'll leave that there.